Oops. Dear friends, welcome back to the project Snow Queen. Today we're talking about physical principle of our novel refrigeration system. We discussed in previous videos how low temperature refrigeration is important to produce superior products and services in such critical industries as food, healthcare, and energy. Low temperature refrigerations from -30 to -200 degrees Celsius are provided with conventional refrigeration system. So how do they work? Well, two principles. First, compression of the refrigerant gas, and two, acceleration of this gas. So let me demonstrate you on how it works on a simple example. So imagine that this balloon is a conventional refrigeration compressor. Well, first we have to compress the refrigeration gas. So now when the gas is compressed, we can accelerate it, and while it is accelerating, its temperature goes down. So we obtain this refrigeration effect, and you can try it at home. So we start accelerating it, and this acceleration causes the cooling effect. Very simple. The only problem is that the lowest temperature that we could economically obtain with this approach is -50 degrees Celsius. If we want more, we need to compress this gas more in order to give it a chance to accelerate with higher velocities and therefore producing lower temperature. But let me demonstrate you what happens if we compress it too much. Oops, sorry for that. Well, what are you going to do about this? In order to get temperatures lower than -50 degrees Celsius, we need to use the second compressor. Well, and in this example, we could achieve temperatures lower than -50 degrees Celsius, about -100 degrees Celsius. Well, let me show you how this works. We first compress refrigeration gas in the first compressor. Then we do the same thing for the second compressor. So now we have two compressors, and we use the first one to provide the cooling effect in exactly the same way as I showed previously. But we use this cooling effect to cool down the second compressor. So it looks like this. We cool it down with the cooling effect. And now when the gas in the second compressor has a lower temperature than before, we could then accelerate it again, but this time the temperature will go lower. So to about -100 degrees Celsius. Well, very simple, isn't it? The only problem is now we have two compressors. This means double cost. We have to use 2 times more energy to compress gas in the second and in the first and in the second refrigerator, And also their interaction becomes more complicated because the chances that something goes wrong with two compressors are higher. Therefore, the maintenance cost also goes up. Well, okay, what about minus 150 degrees Celsius? Can we achieve that? Well, yes, and I hope you guessed it. We use the third compressor, and all these problems just multiplied by the factor of 3. And additionally, you also have to use greenhouse gases, very complicated refrigerant gases, in order to operate this complicated system and obtain temperatures below minus 50 degrees Celsius. If we need even lower, we use liquid nitrogen. Well, liquid nitrogen is produced in centralized, specialized facilities, and then is transported using sophisticated logistics system and equipment, and then has to be stored at the facilities of users of this liquefied natural gas. And all of this is just inefficient. Can we do something about it? Can we use a different approach for refrigeration in order to allow affordable cooling effect for superior products that we talked about in the previous videos? The refrigeration brain. We built a system that uses different refrigeration approach, and it can use just one compressor and reach temperatures minus 200 degrees Celsius. How do we do this? Well, one simple word: memory. Memory helps humans to remember more and be more productive. Memory helps computers to process more information and therefore produce more complex tasks. In a similar way, memory helps refrigerators to be more productive and produce lower refrigeration temperature. In order to do this, as I said, we need one compressor, and we add one element: the refrigeration brain. So how does this work? Well, you all know when you forget something and cannot memorize it, then you have to look it up again in order to make a decision, and therefore you waste time and energy. But when in the moment of memory loss you suddenly remember it, your brain tells you the answer, you become very, very efficient and productive. And similar way happens with the refrigeration. The refrigeration gas does not have memory. It cannot remember what was the cooling temperature when it was compressed and accelerated the last time. So now we compress the gas, and if we accelerate, we will achieve the cooling effect. But then the next time, the gas wouldn't remember this cooling effect, this refrigeration temperature, and we will have to compress it again, and then accelerate it again, and repeat this process many times. Well, this is how conventional refrigeration system works. Now we add the memory effect. We allow the refrigeration brain to remember the cooling temperature, or the refrigeration temperature, when the refrigeration gas is accelerated. It memorizes this temperature, and the next time we compress the gas, we use the neurons of this brain to remind the gas how to be in the state where it has low refrigeration temperature. So we compress the gas, we now accelerate this gas, the brain memorizes this negative temperature, and now we're compressing the second time. So let's say the first time the negative temperature was minus 20 degrees Celsius. Now if we accelerate the gas without the brain, we will again obtain minus 20. But the brain remembers that minus 20 was the last time. We connect it to the refrigerant gas, and neurons reminds the gas how to be minus 20 before it accelerates. So now, before the acceleration, gas has minus 20. Now we accelerate it and obtain even lower temperature, minus 40. So now the brain memorizes minus 40, and the next time we compress it, we plug the brain again in, and the brain reminds the gas how to be in a state of minus 40 before it accelerates. And then after the acceleration, the temperature goes even lower to minus 60 degrees Celsius. And then the brain remembers it again. And then the process is repeated. We obtain minus 80, and then minus 100, and lower until we reach minus 200, and sometimes even lower. And we can do this reduction of refrigeration temperature with this approach quite fast. So from the room temperature to minus, for example, 120 degrees Celsius, we can go in 10 to 15 minutes. And while understanding the DNA of this process, we could also control the speed of refrigeration and the refrigeration temperature that we want to use in order to produce the cooling effect. And this will allow, as we believe, to enable the development of superior products of the future with affordable and controllable refrigeration. And because we use just one compressor, it is 3 times cheaper. It is about 2 times more efficient, and it does not use greenhouse refrigerant gases, which sometimes can be even dangerous for operators who control this complicated conventional refrigeration system. In our case, it is the noble refrigerant gas, which has zero impact on our environment. Thank you very much for your attention. In future videos, we will talk specifically on the example of our system, how it could be useful for different players in the value chain of producing products using the refrigeration. See you later. Bye-bye.